Muy bien, buenos días. Pues vamos a comenzar el segundo día de las jornadas en Madrid. Antes de presentar al primer conferenciante, deciros que tenemos ahí a la derecha el Twitter y os animo a todos a tuitear vuestros pensamientos, lo que se os ocurra, ¿no? Con el hashtag eMadridNet. Bien, en primer lugar tenemos hoy una conferencia invitada también de excepción. Se trata de Marcus Pecht, que va a disertar sobre el tema Linking Sensors, Actuators and Learning. Marcus ha estudiado psicología en Alemania, con un énfasis en sistemas adaptativos para educación y sistemas inteligentes de tutoría. Y después trabajó en la empresa, en particular trabajó en el Instituto Fraunhofer, en el Departamento de Conocimiento Móvil, Mobile Knowledge. Y desde 2005 es catedrático, es profesor en la Open University de los Países Bajos, profesor de tecnologías avanzadas del aprendizaje. Por tanto, una persona muy experta para hablarnos de, precisamente, el mobile learning, el aprendizaje móvil. Cuando quieras, Marcus, thank you very much for accepting to give this talk, and whenever you're ready. Thank you.
Thank you very much for the introduction, for the invitation to come here and talk a bit about our work. There's a little feedback here, I think. Okay, so what I'm talking about today, is that better? I give you a bit background where I'm coming from. The Open University in the Netherlands, we have about 8 faculties. We have an associated research center, the Center for Learning Sciences and Technologies, where I'm working. I'll just try to move this in a different direction. Probably that's better. You find all information about the work we're doing, about the research programs, the lab activities on cellstack.org. We also have a presence on iTunes U and YouTube Edu, so you find some video material, video footage from the faculties, from our university on these channels. And basically we are at the moment investing in a new initiative, also a new kind of model on community-based learning support that's on openu.nl. From the research side, we have about 3 programs in CellStack. CellStack has about roughly 100 full-time equivalents, a bit more. And we are looking at learning from different perspectives. Paul Kirschner, you may know, he's heading the program on learning and cognition. We have a perspective learning networks for professional development that is headed by Peter Sloop. And Wim Westerer and me are heading the Learning Media program, where we take more or less the media perspective on learning support. So this is a bit the research part. We have our own master program and some strategic activities, more on open educational resources, I mentioned just with OpenUNL. To give you a bit an idea about one other activity of mine, which is running the Learning Innovation Lab. Basically what we do there is end-user workshops, working with new technologies, working in strategic groups, like what is the potential assessment for new technologies, use cases, use scenarios, and just hands-on practices. And I give you a very short introduction about that. Don't know if we have audio also from this.
Every day I'm on many social networks.
I'm on MSN.
Twitter, I'm on Hive. I'm on LinkedIn, I'm on Xing.
Skype I'm on, online all day.
So these are all colleagues from
I
mine.
use Delicious every day to memorize and share with my colleagues.
It's all about interaction, having access to worldwide resources.
We use the technologies ourselves in the lab.
Mobiles in the classroom, mobiles in general will be universal tools. You can drop all kind of software and applications on it, and we will use it for different things.
I couldn't live without it anymore.
Most of my life is online. I'm quite sure it's a form of addiction. It's an addiction to
Okay, that's an interesting point. Sorry, I just need to switch
information.
off
The easier
my other audio channel here. So, here we go. Okay. So, I want to end with the last part where the colleague of mine, Stéphane Tanier, mentioned these are kind of also addictive technologies. And that's actually the starting point for my talk. So, you might heard of Space Invaders. This is a website from an artist called Invader. And he detected intrusion of aliens and alien technology. Luckily, it only happened in Spain, in Barcelona, not in Madrid yet, so we're safe. But the point for today is that we did research in the last 10 years on this problem, so we anticipated a bit of that. And I will give you some of our findings to prepare you for the further invasion. Basically, most of the things started when Mark Weiser came up with the notion of ubiquitous technologies. And an artist built a small thing called the dangling string. Basically, it's a plastic spaghetti hanging from the ceiling, attached to a motor, and it was like an early detection system. So the motor rotation was connected to the network traffic. So if a lot of people would access the broadcast of this talk, we would hear it as the rotor speeds faster or turns faster, and the pitch of the plastic spaghetti would get up high. So it would make a lot of noise. And so this was a kind of starting point where you have an embedded display in the environment. You had a sensor, basically a sensor taking the network traffic and implementing that or connecting that to the rotation of a motor and to a sound from which a human that can perceive the sound can learn something, probably. Yeah? Then developments in 2005 got more and more dramatic. I think it's very nicely described, the scenarios in the book of Adam Greenfield, The Dawning Age of Ubiquitous Computing. He describes it on all kinds of levels. So just to give you an idea, with basic or with experiments like adding sensors to carpets, you can detect with a probability of about 80% the gender and the age of a person walking on this floor. Yeah? So it's happening everywhere. It did happen everywhere. And the difficult thing about it is that we didn't realize the change. Often we just didn't realize it. We use a newspaper in the morning. We want to read our newspaper.
The new Newsday app is better than the newspaper in all kinds of ways.
This is the marketing part now. But
Except for
the
one.
fly, you couldn't see the fly. There was
Get
a fly.
Newsday
You want
every
to
day in a
crash your
whole new
fly,
way.
and you realize suddenly it's not a newspaper I'm holding in my hand. It's something different. So, and this happened even faster. So all the development is speeding up. Every year you get like, now in 2007 it has been 1.2 billion mobile phones being spread out every year. In 2014, more people will access the mobile internet or the internet via a mobile device than a stationary device. So this is really a rapid movement and development of the integration of new kind of technology in our everyday life. And of course, on the one hand, they are used for tracking also. Just recently there was some discussion about iPhones tracking you and Android devices tracking you and storing that on a server or on your mobile device. Nevertheless, we can use this technology also the other way. One important thing, if you talk about tracking, is that mobiles have a lot of sensors built in. So they can already sense a lot about your environment, where you are. And the important issue is that you carry them with you. I mean, whom of you has a mobile phone with you? Okay, so a lot of you can be tracked, but you can probably also use it for different things. An interesting comparison is if you come from the background of cognitive psychology, as I do, perception qualities of humans and how do you perceive things. So what parts of a scenario can we sense, and for what parts of your environment you already have sensors either built into mobile technology or attached to a mobile device. So for light, sound, temperature, magnetic, electrical, even you have some sensors that humans don't have. Chemical sensors, for example, or certain ultrasound sensors, which are also used, for example, in augmenting human perception. And there is a lot of engineering going on in that area, using these sensors not only on the raw data level, but also on higher levels of abstraction. What I mean with that is you have a light sensor built in your mobile phones. In most of the smartphones, you have these light sensors. And you can use this to detect if a person is indoors, outdoors, the lighting condition of the room. If you combine that with an audio sensor, you can, so the more sensors you combine, the more precise you can get on identifying the context of a person. Of course, this is a problem. Context detection, context analysis, there's a lot of research going on to this. I'm not talking about that in the sense of like we should have or we will have an AI system that can identify very precisely our context. But what I would argue for is that in most cases, it's sufficient to identify a part of the context that is relevant. And this continues currently with developments with biosensors that can then additionally get some information about the user status. Yeah? So basically, you can perceive a smartphone or mobile device as a kind of sensor pack you carry around with you. Yeah? And the question is, what can we do with that? The other question from a more psychology point of view, so does that really make a difference, if things become smarter, that you carry around with you, that people, that things that can sense something or perceive or collect data, however you want to take it, and what is the impact on a learning experience? And there are certain studies from the field of psychology on that. One example is that is a project from Microsoft Research, SenseCam. Out of that, also a product was developed. Basically, what you can see on the lower part image, it's a kind of, it's a camera with sensors, and the sensors detect if I move, if the lighting changes, and every time the lighting changes or a movement takes place, basically it takes a snapshot. And in research, this was used, like you had then a kind of movie of the day. So this was used with amnesia patients to give them a better recall of what happened on this day. And they basically, in experiments, could show a significant impact on the recall rate, that you can reconstruct what happened on this day. And basically, this goes back to some principles of episodic memory, how the information is stored, and things like this. So if you connect sensors and new media in the right way, this can support learning, this can support recall, these kind of things. Another experiment we did is more from the perception side and from the immersion side. This is a project from 2001. It was a European project called LISTEN, and basically what we built there is a tracking system. So you will see in a second the person having some strange things on his head, but basically this was used to detect the location of a person up to 5 centimeters in a room and the direction where the person is looking up to 5 degrees. And we built an audio environment for a museum that gave you an introduction, in this case, to the Macke exhibition in Bonn.
You have just stepped across a boundary. You have entered another room. A sound room full of sounds which are set in motion by your movement. Step in.
In a small hotel room in Paris, August Macke painted this self-portrait in 1909. He was on his honeymoon with Elisabeth Gerhard. The back of this small wooden panel still carries the stamp of the shop in the Rue Bonaparte where he had stocked up on wooden painting panels. A half-portrait, his face in three-quarter profile,
So what
an
you could hear a
inquiring
little
look
bit,
into the
the
mirror,
sound was really in
his posture
3D,
somewhat stiff.
rotating while you
Thus
walk.
far,
So the sound
a
always
classical,
came from the
traditional
panel.
portrait. But then Macke places a light colouring around his body and head, like a natural shading. He overpaints the background of the room, together with all the furniture and his left hand.
So just to give you an idea and to add a short personal anecdote, in this case the authoring environment was a virtual world in a cave system. So basically you could walk in that museum, also in the virtual representation of that museum, and you could place audios or sound sources with this authoring tool, and then the sound was coming from that direction. And I remember a scene when I played around with the system, and I was standing in front of a painting of August Macke, and there was really a very immersive effect on this when the audio started, and you exactly at the moment when you focused on the artwork. Yeah? So immersion is there an important part, I would say, that we can achieve with sensors. A better synchronization with what we do with the environment and the technologies. Recent developments, and we did some work on this, are coming up in the field of augmented reality. So basically in the last 3 years, mobile technology developed so fast that you now can do augmented reality with mobile devices, not only with stationary devices and big computers. So this is a small game we implemented as a prototype, which is based on the principle of the memory game, a card turning game where you have to find pairs. In this case, what you have to find, you can see cards in the overlay, and then if you turn the cards, there is a picture on it from, in this case, from the sculpture. And if you find the real sculpture, you can walk there, drop the image, and you get a point. And then we tested different scenarios where you can also play this in teams or groups together. So basically this is just a prototype for linking kind of logic, game logic in this case, also collaborative game logic with a real world scenario. Yeah? And I think sensing in that sense also plays on a lower level, like new types of interfaces. This is my son playing with a small iPad app. I found very interesting. I mean, when he did that, he was 2. But by touching the letters, he heard the sounds of the letters. And when creating the complete word, he was kind of like reinforced to, okay, this is a cat, great, you did, and he really liked it. He really went for that for all versions of like animals, food, toys, whatever. So that's very interesting. So on the one hand, there is a different form of interaction, and additionally, there is also a different type of discourse. So if you look at recent developments in like tabletop interfaces, this is really triggering a different kind of interaction between people using these media. Yeah? I give you, I mean, these are examples just from either leisure part or a medical application on the Microsoft Surface table. This is another example from a project we did. It's a project that now is a foundation, the MACE Foundation. You find the whole website and the materials online about MACE project. And basically the idea was that we had, as a starting point, several databases from the field of architecture, project databases, picture databases, cases, yeah, all types of materials. And we created a common metadata database so that you can search in all these, yeah, and find, for example, you type in a topic or a location, and you find all images, projects, cases relevant for that concept, for example. And then you can search, so you can build classical interfaces. Like in this case, it's a kind of a setted browsing interface that is, you can also explore it yourself online. Basically, you can set a building type, an architect you're interested in, and it will then adopt the rest of the widgets on this page. Basically, it will show you where this architect has built most of the buildings on the map widget. All the stuff below is adapted. So what you select above is a kind of filter you apply to search in the database. And one other interface we built on top of that, and this is to illustrate my point about a different type of discourse, is that one. That was an exhibit at the Biennale in Venice in 2008. And basically it was a table. And what we did is we made cards, and on the back of the cards you had a symbol, a code, that when you put them on a table, a system could detect what this object is. So you throw the card on the table detects what kind of object this is, and the connections you see between the cards are basically based on the metadata we have in the backend. So we know, for example, that these objects are from the same architect or that they are from the same period of time. And of course, this can be used by several people, and you can have a discourse about also missing objects. So you see some cards are virtually added. So you would say, okay, there's one missing link in a sequence of buildings that this architect made. Yeah? And explore that database. And to connect it one step further, we also built a mobile access to these databases where you can also enrich the information in the databases. So one very powerful scenario, if we talk about mobiles and sensors, is that you can use your mobile, and you see that also in studies already from 2002. So one of the first functionality introduced to mobile devices were cameras and then GPS location tracking. So you can take pictures, and this is what we support with this app. So you walk around, it basically takes your location, it filters and gives you a list of buildings or projects relevant around you. You can walk to these buildings or add a new building, and then basically you can take photos of this building, and you can annotate the photos. As for architects, in that case, it was very important that they could annotate pictures to highlight certain concepts. Like, let's say, this is a special type of facade, how it was constructed, and this is what I want to highlight or what I want to have a discussion with my peer students about. Yeah? And we did an empirical study with the Faculty of Architecture in Barcelona. And basically the impact was of course, that these students were more active. We compared a group just doing classical web research about they had access to the same materials, but they haven't been going out and mobilely taking pictures or annotations. And the student group that went out got much more interested, motivated, engaged for further discussion. This was one main effect we found. Okay, so in principle, sensors can make a difference. This would be my point. And there are different variations of that by simple different types of interfaces, different types of interactions. I didn't talk about object interactions. I will talk a bit about that later on. But on the level of taking images with locations, combining episodic tracks of the day, these kind of things. So there can be a real impact also on learning and on cognitive functions. One other part of the research we did is how can we build such system and build abstract models of such systems to come up with new ideas, what we can do with that. And basically, we developed a model that has 4 layers. On the lowest level, you have kind of sensors, and these can be, if you come from traditional distance education systems, learning management systems, whatever, you have classical sensors like selections of users, questionnaires, quizzes, whatever. So we consider this as a type of sensor, but also the environmental conditions, temperature sensors, the time. These are also types of sensors we can integrate to create a richer track of the user. And then on the second level, this must be combined. So to give you an example, we connected physical objects, the buildings in the real world, with messages or with a document about that. And on the level higher, we basically specify the instructional design. So what do we want to happen? Let's say the user starts, and then depending on an activity at a physical object, either the user goes to activity 2 or to activity 3. Yeah? And on the highest level, then of course you need to have different interfaces with which the user can interact, yeah? And through which information can be sent to the user. These can be mobile devices, this can be stationary displays, and they have different effects. Just to give you one example, it will have a completely different impact if you give information. Let's say I would give the same information about how many users participate remotely in this lecture to you on your personal devices, compared to, I would have a display here showing the number. And just think a bit about the difference what the effect of this would be about our discussion or about the presentation. You can read about that in a paper from 2004. We also did an analysis of the types of learning support. We analyzed about 50 systems, about the type of content they use, like notifications, images, documents, about the type of context that was used in a lot of cases, like the location, the room you are in, the purpose, the information flow, and the educational models behind it. And coming from that, we developed a model I will shortly introduce you to. That's the model of ambient information channels. And basically, it's a simplified model to describe like context-aware systems for learning support. So the basic components in the model are, of course, we have users. In this case, only one, as I just depict the type of entity. We have channels that can be media channels, like this presentation. We have artifacts that can be objects, like this bottle or the computer or the chair. It's about linking real-world objects to channels. And you have several processes that happen on these 4 layers I mentioned before. So the sensor information must be aggregated. That basically means that you can have different sensors telling you something about the environment of the user. So you map them together that you can access this from an engineering side, easily just access the user object and have the information about the environment. Yeah? In the next step, probably then you basically enrich, in this case, for example, the user context information with all the aggregated sensor information that you know where is the user in a lecture, is the user busy, free, whatever. And then we come to 2 last steps that are more interesting from the interaction and from the learning part. Basically, the synchronization. There you describe decisions about the learning logic and how the real-world objects, I stick with the building, how the media channel and how the user are synchronized. Yeah? A simple model for that would be, let's say you come to this room, you listen to a certain audio stream. Yeah? And now you could have different effects you want to achieve. Let's say you would like to have the effect that the audio stream wanders with you if you go to the next room, yeah? As it's probably a communication or an audio conference you want to follow. So basically then you would just detect the next room and the audio stream would wander with you. Yeah? So type of synchronization. And if you have several displays, and you will see some examples about that a bit later in the presentation, you also come to the reflection part. So you could have 2 different channels. A lot of things, or one good example might be that you are in the zoo. You're standing in front of the lion cage, and there you get a presentation about the background about that animal. And what you would like to do is like you compare tigers and lions. So you would have a second channel that is basically synchronized via the identity. So you know, okay, now the person is looking at tigers, so I give him all these types of animals to understand the difference, where these animals live, for example, or what is similar about it. So it's a lot about metacognitive support. So, and if you apply these models and you use these models, you can basically classify a lot of systems and you can develop some new ideas. This is a design mock-up, not by us, by MetaMirror, that gives you an idea of what could also be a kind of ambient information channel. Basically, it's you watch your TV, you take out your iPad, the iPad can detect what TV channel you're watching and give you additional information like game statistics, in this case for the soccer game statistics, interfaces to associated services, all these kind of things. Yeah? How would this look, such an application, if you model it with the ambient information channels? Basically, you have your TV and you have a mobile device. Both have contextual information, yeah, with these 5 categories. You would synchronize the channel I watch on my TV with the channel on my mobile device. And of course, you can access via that any kind of resource, like a discussion forum, a chat forum, reflection about this documentation. It can be a political documentation that is online, and you just are connected to the forum in which similar questions are discussed. That would then already be the next step. Via that, you could also link, of course, with other peers that are remotely access the same identity. Yeah? Or the same channel with the same identity. So this is a bit about the modeling part. What is the research we are currently focusing on at CellStack in the mobile part? So on the one hand, we want to understand how new types of content come up. This is a nice example from the Open University in the UK. They have a lot of EPUB books in iTunes U. You can download for free. This is one about Schubert's Lieder. What I really like about this book especially is it's a very nice combination of text and audio information. So as you read the text, you can click here on use it on your iPad normally or on your tablet computer. You click here and you listen to the Heide Röslein to get an authentic audio recording that really gives you a very immersive effect into what you are reading here. Yeah? It gives you a personal experience. So what we are looking into and what we are interested in, if we can extend these books with kind of feedback and achievement systems. Yeah? So tell the user, okay, you have been really active reading these kind of documents, and mirror this information to the user to support reflection of your own learning process. Yeah? And you can do this on different levels, and we have some research ongoing on how this reflection amplifiers, how we call them, should be constructed. Yeah? So this is me reflecting about Schubert. Okay, a second part that's a bit more related to the work I mentioned, like embedding interfaces into the real world, is inspired by some work on informative art. You find this, if you Google informative art, one basic idea that was done in this research in Sweden was, for example, to take a kind of Mondrian's artwork hanging on the wall, making a digital version of this, and mapping the design to sensors. Similar like the dangling string. You just would hang this on the wall, a display. It's a display that can dynamically change. And let's assume it's associated to the traffic situation around the campus. So, and the worse the traffic gets, the more red will appear in the picture. Yeah? Or also map it to the temperature. You could map it to any kind of sensor. There we're back by to the modeling part. And what we are currently looking into is some work in what we call ambient displays. And there are several examples of that, of kind of ambient displays embedded into our environment. The ambient umbrella is an interesting one. That's an umbrella basically, it has a small LED light attached here. And when the forecast says it will rain today or in an hour or two, it blinks. So it gives you some warning, okay, probably take your umbrella with you. And there are different types of this. So what we did is we did an analysis on what kind of dimensions you have with these displays embedded in your environment. They have different levels of information capacity, of representational fidelity, aesthetic aspects, and they have also different kinds of, or a range of different levels of intrusion in the environment. To explain that a little bit, this is just a little orb, a digital ball or lying there, and you can map certain information to the lighting of that ball. Is it red? Is it green? Is it blue? So it gives you very basic information about some things you define you want to know. Yeah? But of course, the ambient display can also be something like attached to the wall that gives you the schedule for this lecture hall, for example. We would also consider that as an ambient display. So you see there's a whole range. And what we're interested in is then, in a second level, to associate these displays with certain learning activities. Yeah? This is a reworked Bloom's taxonomy, basically, and you say, okay, we want people to remember things, so how would the ambient display need to be designed? And we recently did one experiment by putting displays in the different buildings of on our campus. And on this, we presented information to the staff members about how you can save energy. And there were different variations. There were basically two variations we looked at: the type the information was presented and the notification level. So with some parts or with some displays, when you walked past, there was a camera attached to the display, it could detect that you passed by, and it gave you a short bing, like, look at me. And the other part didn't. And one interesting first finding we have is that this attraction, this notification on this level seems to work quite well. So in that sense, that the people that were working in a building with notification displays took more of the information with them than the other group. But okay, this is like first reports. There will be a paper soon published about that. And one last short or small project I want to give you an idea about is that we just thought about, okay, we want to have actually a learning management system available everywhere and connected also to the room activities. Yeah? There's a whole research group, and research groups are active now. How can you, for example, connect digital resources to this kind of lecture room in a sensible way, and also to the setup? So in this case, it's quite set. It's kind of auditorium. I do a presentation here, you sit there. But there are more flexible setups probably in which you could use digital resources in different ways. Or even in this room, we could come up with different instructional scenarios, how to use the room the best way. In that sense, we connected the learning management system. Each Moodle page basically was connected to a room. And when you entered the room, the page popped up on your mobile device, and you could see, for example, what you could do in that room. So if I would come in that room and I'm logged into the system, it would detect my role. So I'm a presenter, and I could just launch my presentation or launch a video on the infrastructure here. So I use my mobile device as a kind of remote. Yeah? And this is dependent on your role and the instructional design for this room. It could mean, for your case, if we have a kind of classroom response setup, that you enter the room, the system knows there's currently a presentation going on, and if you open your mobile device accessing the Moodle page, you would have a feedback button, like, I like this, I don't like this, for example. Yeah? And we want to better understand how we can support educators to design these kind of instructional designs, to create them, and then also how to technically deploy them. So, coming back to the invader, I have some final kind of questions, recommendations for you. If you want to use this kind of technology invasion for your purposes and for learning support with your organization. So, the first question I would ask: are your contents and legacy information systems accessible by mobiles and ubiquitous technology? Simple question: did you ever check your web page of the organization on your mobile device? Can you read it, or can you not read it? I mean, really read it relaxed, not like scanning or zooming 3 times until you can read the first sentences. Yeah? So is it usable? And this plays on this simple level up to like services. What we've seen, for example, in simple things like directory services. So in our university, we use at the moment Blackboard as an operative system for learning support. And Blackboard has recently, or in 2009, bought a company from Stanford that basically builds a mobile interface to a whole Blackboard system. But as soon as you want to make these services available on a mobile, different requirements come up for your legacy system. For example, one module they have on the mobile is you have your lecture, your study plan. You want to go to the next seminar. Where is the seminar taking place? Where is the office of the teacher? And for that, you need a well-updated directory service with all the stuff in, also with the locations in there. And without that, you're losing some part of the functionality. Yeah? A very interesting question you could ask yourself is, like, I gave the example of architecture. So for some domains, it's much more easy to come up with examples where you argument, okay, here this learning support is connected to real-world objects, buildings. That's simple. It gets a bit more difficult if you think about probably mathematics. Again, it gets easier when you work with cultural sciences, all these kind of things. So the interesting exercise we're doing now, not only on the university levels, but also with schools, is like, for what subjects and what domains you actually need to have this connection with real-world objects, and where does it help, yeah, from an educational perspective. One domain we did that was looking at different patterns for using augmented reality for math education, geometry education, but also for higher education. A third one that is actually connected to what I just said is, so where does this connection really bring an added value or a deeper learning experience or better scaffolding? So really coming from educational impacts you have from this connection of the real world, digital content, and the sensory information. And then a more engineering question, how can you capture that context? And a last one, how is this access on your mobile device? I gave the example of ambient displays. So you should not only think about a mobile device giving support and giving access to the information, but of course it's connected to other displays, other facilities, physical room layout, these kind of things. So how is this related? Okay, thank you. The sensor is there. Yeah, okay. This is the actuator. Correct. Yes.
I don't know whether this is the question. Need to identify the sensor link between your content and the real world that suits your learning goals.
Mm-hmm.
It's more a general reflection. Content, the real world that suits your learning goals.
I mean, what we are currently looking into, basically like I said, we kick off activities with different schools and basically with different faculties. And what I think that also is shown by experiences from other organizations, that you need to think about the most powerful connections for a certain domain. Yeah? In cultural sciences, that's relatively straightforward. Yeah, you can use location. For psychology, for example, we are at the moment focusing on notifications. Yeah? because what they are interested in is real-time data capturing. For example, they do studies this is now not related to the educational part, but more to the research part. But they do studies on headache, for example, and they want to learn how the environmental conditions or the context or the situation of a person is related to the development of the headache, for example. So with them, we use something like called experience sampling method, and that basically can trigger a question to a user by the development of the weather, let's say. The system has a rule that triggers as soon as temperature and humidity rises above that level, send out a question or a small questionnaire to all our users. Additionally, you can take into account the location, and then you collect the data this way. So in this sense, I think you really have to think about the domains. And to give you one example from an organization we're working with, that is Fontes Hogescholen in the Netherlands. It's basically a college with about 40,000 students, and what they did is they gave mobiles and iPads to 200 of these to different faculties, to arts, to computer science, to psychology, and asked them, what would you do with these devices and with these kind of applications? And they got a whole really kind of grassroots approach for finding the best opportunities.
Here, do we have any question? If not, thank you once again for your very inspiring talk.